Okay, lesson 2, electric field strength calculation. So we have 3 here to look at. So the first one, a charge of 5 microcoulombs. So we'll make our list. Okay, so Q is 5 by 10 to the minus 3. Force of 245 micronewtons. So the force is 245 by 10 to the minus 6 newtons. These are off page 45. The magnitude of electric field strength. So we're looking for the magnitude. So that means we're not interested in direction. Doesn't mean for direction. Okay, so now think about it. This charge is experiencing a force in the field. So this is effectively a test charge, a charge that's being thrown into the field, and we call that small q. And it should be pretty clear from what information you have that we're using the definition, E is equal to F over Q. So we have 2 of the 3 bits, so we're in business. So 245 by 10 to the minus 6 over 5 by 10 to the minus 3. Okay, and we end up with an answer of 0.049. Let's remember the unit, newtons divided by coulombs. Newtons per coulomb, leave a space. Okay, that's it. No direction involved, we weren't asked for direction. Question 2, calculate the electric field intensity, okay, at a distance of 16 nanometers. So the distance here is 16 nanometers, 16 by 10 to the minus 9, from page 45, from an electron. From an electron, remember, charging the electron, we're very comfortable having done the atom. We're constantly using the charge of electrons. In this case, charge of electron is Q, and it's 1.6 by 10 to the minus 19 from our pages 46 and 47. Okay, in this case it's Q and D written for electric field intensity, so it's the other one. Okay, now it's the one where it's this, which you have to know. So remember, if you want, Coulomb's law. But the charge is 1, okay, the test charge is 1 coulomb, and the force is then the electric field strength. So that's that. So I think it's just a case of making sure you know it. You'll be using it a lot. Okay, Q, so 1.6 by 10 to the minus 19. Now this is a different Q, and in effect I should have written it like this. So go back and do it. This is the charge that's causing the field. Okay, the electron is causing the field, and you're asked for the electric field intensity within the field. So this is the other type. Okay, over 4 pi, 8.9 by 10 to the minus 12 again. I'll write that in over here. Okay, sorry, haven't done it yet. Remember, that's permittivity, which is on page 47 as well. Okay, so the permittivity on page 47, it's a constant. So that's the permittivity to vacuum, more correctly, E0. Okay, and we looked at it, remember, in yesterday's lesson. Okay, and we don't forget to square this, something a lot of us are forgetting, and we end up with 5.59 by 10 to the power 6 newtons per coulomb. Now we're asked for the electric field intensity, so we need magnitude and direction. So we need the direction. So in this case, it's an electron. If we put a test charge into an electric field from an electron, it will be attracted towards the electron because it's a plus charge, and it'll go to the negatively charged electron. So we write in the direction just as simply as that, towards the electron. Okay. Rewind if you're not sure. Question 3. The dome of Van de Graaff generator has a diameter of 25. So, okay, so we have our Van de Graaff generator, which is just a spherical container which has a diameter of 25 centimeters. Okay, a charge, so, is placed of 4 millicoulombs is placed on the dome. So the charge in the dome, which is going to provide the field, is 4 by 10 to the minus 3 coulombs. Calculate the electric field intensity at a distance of 3 centimeters from the surface of the dome. Now remember, it's important, if the charge has dimensions, in other words, not a point charge, we always measure to the center. So in this case, we'll be adding 12.5 centimeters, won't we? So the distance from the point to the center of the dome will be 15.5 centimeters, or 0.155 meters. Okay, we have our permittivity from our tables. Okay, so we're in business. So again, it's this one, which is going to be the much more common formula, and we're going to fill it in. So 4 by 10 to the minus 3 over 4 by pi by 8.9 by 10 to the minus 12 by the distance 0.155 squared and we get an answer here of 1.49 by 10 to the 9 newtons per coulomb. And again, the direction, now we were told it was a charge of 4, so that implies plus 4. So in this case, a test plus charge put here would be repelled, so it's away from the dome. It's the opposite direction, because in this case it's a plus charge, in the case of the electron it was a negative charge. Okay, there you go.